Hello friends, in this video we are going to discuss about the Fourier series expression of phase voltage and line voltage for 180 degree conduction mode 3-phase inverter. Okay, so in the last video we have derived this expression VAN of omega t is equal to summation over n is equal to 6k plus or minus 1 up to the infinity 2 VDC by n pi into sine of n omega t. Okay, where k is equal to 0, 1, 2, 3 up to the infinity. Okay, next similarly can we write the VBN of omega t? Yes, VBN of omega t. So if you check, VBN is lagging to VAN by angle 120 degree. So this can be written as n is equal to 6k plus or minus 1 up to the infinity. Yes, it is 2 VDC upon n pi. Okay, this will remain same into sine of, this can be written as n into omega t minus 2 pi by 3, right? It is lagging by 120 degree. Okay, VBN. Okay, next similarly VCN we can write VCN of omega t is equal to VCN of omega t is equal to, yes, it is a summation over n is equal to 6k plus or minus 1 up to the infinity, right? Same 2 VDC divided by n pi into sine of n into, this can be written as omega t, either minus 240 degree we can write or plus 120 degree. Okay, in both the ways we are having the same meaning. Okay, so this is the expression for phase A voltage, phase B voltage and phase C voltage. Okay, so from this can we say that yes, in the output phase voltage, right, in output phase voltage of, yes, we can write output phase voltage of 3-phase inverter of 180 degree conduction mode, 180 degree conduction mode. Okay, or we can write in, okay, conduction mode, all even and triple n, very important, all even and triple n harmonics are absent. Okay, so in the output voltage of 3-phase inverter 180 degree conduction mode, all even and triple n harmonics are absent. Is this clear? Okay, so this point is very important. They have asked the questions, okay, in the phase voltage, okay, in the output phase voltage, very important, right? So phase voltage we are having. Okay, similarly here we need to understand what is the fundamental RMS voltage. Okay, fundamental RMS voltage, it is a 2 VDC by pi, it is a peak value, right? So divided by root 2 is nothing but root 2 VDC by pi, that will be your RMS value of the fundamental peak voltage, right? So this we need to understand, right? Next, similarly if you check the line voltage, okay, if you check the line voltage, in the line voltage we are having the wave shape like, if you recall the line voltage waveform, okay, so line voltage, yes, it is having the wave shape of, it is having the wave shape like, yes, quasi square wave, right? Quasi square wave, and what is the pulse width? And pulse width is, it is equal to 120 degree, right? Pulse width is equal to 120 degree. Is this clear? Okay, so we are having the pulse width which is equal to 120 degree and the nature is the quasi square wave. Okay, so here can we write the expression for the line voltage? Yes, we can write the expression for the line voltage, right? It will be in the same way, as that of whatever we have discussed in the single pulse width modulation technique. So here in that we are having, yes, we can write it as a VAB of omega t, VAB of omega t, right? So line AB voltage, Fourier series expression I am writing, okay? So it is nothing but, yes, it was a in the single phase, right? It was a 4 EDC by n pi, okay? So it was a 4 EDC by n pi, right? So corresponding the magnitude was EDC, right? But here we are having the VDC, so we can write it as a 4 into VDC divided by n pi okay, into, or we can write it in terms of summation, right? Okay, so it can be written as here, yes, I am writing it as summation over n is equal to 135 up to the infinity, okay? So it is a 4 into VDC divided by n pi, 4 VDC by n pi into sine of n delta by 2, right? Into sine of, very important, please try to understand this expression, n into omega t, okay? It is actually leading by 30 degree, okay? So it is a pi by 6 we need to write, okay? Pi by 6, okay? If you check the V0 we have considered while discussing the single pulse width modulation technique, and here VAB waveform, you will understand VAB is leading to that waveform by angle pi by 6. So it is a n into omega t plus pi by 6. Is this clear? This is a VAB of omega t. Okay, one more important thing, here the delta is 120 degree, right? So we can directly put here it is a 120 degree, okay? And this term for n is equal to 3, this will be absent, right? So we can read, okay, for delta is equal to 120 degree, or it is a 2 pi by 3 radian, okay? So we can write it as a VAB of omega t, VAB of omega t is equal to, now I am going to remove this third harmonic directly, right? Because if delta is 120 degree, definitely the third harmonic will be absent. So it is a n is equal to 1, 5, 7, right, 9, etc. up to the infinity, okay? Only third harmonic is absent. So it is a 4 VDC divided by n pi into, it is a sine of n into delta, right? So it is a n, either we can write it in terms of radian or in degree, right? But here I have written it as in radian, so that's why I am going to write this delta in radian. So it is into 2 pi by 3, okay? 2 pi by 3, right, divided by 2, okay? This is the one term, into sine of, yes, this can be written as n into omega t plus pi by 6, okay? So further we can write this as equal to, yes, we can write it as equal to, is equal to summation over n is equal to 1579 up to the infinity, it is a 4 VDC divided by n pi into sine of, yes, 2 will get cancelled, so it is a n pi by 3, n pi by 3, okay, into sine of n into omega t plus pi by 6, okay? Is this clear? This is the expression for VAB of omega t, okay? So point to be noted, in line voltage, in line voltage of 3-phase inverter, 180 degree conduction mode, 180 degree conduction mode, yes, all even and third harmonic, only third, it is not a triple n, right? Third harmonic are absent, all even and third harmonic are absent. Are you getting the point? Okay, so this is the discussion on which harmonics are present, okay, in the line voltage and the phase voltage of 180 degree conduction mode three-phase inverter. Okay, so now if you compare the phase voltage and the line voltage, okay, in which voltage waveform the harmonics will be lesser? Definitely in the phase voltage, because in the phase voltage, in addition to the even harmonics, we are having the all triple n harmonics are also absent. Triple n means n is equal to 3, n is equal to 6. Definitely 6 is even as well as triple n, but n is equal to 9, right? For n is equal to 9, it is a odd as well as it is a triple n, right? So in the phase voltage, the n is equal to 9, that is the nth harmonic is also absent. Okay, so therefore if you compare the wave shapes of phase voltage and line voltage, yes, the phase voltage wave shape, it is a stepped wave, it will be more closer to the sinusoidal waveform compared to that of the line voltage waveform, which is a quasi square wave. Okay, so this is about the discussion on Fourier series analysis of line and phase voltage of three-phase inverter 180-degree conduction mode and the harmonic contents. Okay, in the next video we are going to discuss about 120-degree conduction mode three-phase inverter.